And we're live. All right. 4.1, solving linear systems, graphs, and tables. So first thing is, a system of equations is a set of two or more equations. We're actually going to do three later on in this chapter. So we'll have like an x, a y, and a z, three equations, three unknowns, but that's later towards the end. The solution to the system, it's the set of all points that satisfy both equations. So when there's two of them, we're trying to find an x, y that makes both equations work at the same time. On a graph, what that's going to look like, and we're going to do some graphing today, is you're going to graph the first line, and you're going to graph the second line, and what we're going to be looking for is we're going to be looking for that coordinate right there, that little xy combination. And that xy combination is the solution to the entire system. All right? So that's our ultimate goal is what is the xy that makes both of these things true. Now, there's some weird things that can happen that we'll talk about on the back side, and you might be able to visualize it, but if I graph two lines, they don't always cross at one point. Could they cross at 2 points? Well, yeah, so I think one option is, look at Baldwin making a cameo. You could have it to where you graph one line, and then the other line is right on top of it, and there's infinite solutions, like the same line. Same slope, same y-intercept. But then you could have a situation, kind of the flip side of that, where you graph the first line, you then come in and graph the second line, and they never touch each other, aka parallel. Yeah. Exactly. So down here, this would be a situation where you can kind of see ahead of time before you graph that if you have the same slope, but then you have different y-intercepts, you're going to have no solution. You're going to be like running parallel to each other. Where this one up here, this would be the same slope and the same y-intercept. One solution always happens if you have different slopes. So that's kind of the first thing you want to check out is, do we have same slope or different? If it's different, cool. If it's just a normal, just good old-fashioned find one answer. All right, well, let's jump into it. So sometimes, like on an SAT, they will give you a system, and they'll just say, hey, which one of the following is a solution? And you can simply just substitute the letters in there to see if it works. So remember on ordered pairs, this is the x, this is the y. I'll give you guys a couple quick minutes, but what I want you to do is I want you to substitute, like in this case, 2 in for x, 4 in for y, and then put 2 in for x, 4 in for y. And if it makes both of them true, it's a solution. But if it fails on either one, you're done. Like it doesn't work. So why don't you guys really quick try 1 and 2, and then we'll jump back in and we'll talk about it. All right, so I'm going to plug these in, and let's see what shakes out. See if they're equal to each other. So on the top row, I get 2 minus 2 times 4 equals 6. And remember, I don't know if it's equal. I'm asking myself, is it equal? Well, that's 2 subtract 8. And I do not think that is equal to 6. So right away, it doesn't work there. So this is a no. This is not a solution. When I put it in the bottom one, 2 times 2 would be 4 plus 4. So the bottom one checked out. So the bottom was yes, but the top was no. But you have to work for both of them to be a solution to the system. Let's try the other side. 2 times 3 is 6. 3 times 2 is 6. Hey, that one looks good. And then 8 times 3 is 24. 24 take away 12 is not equal to 24. So this one was a no. So again, 3, 2 is not a solution. I think that when I typed this, I mistyped it because normally I would try to show you one that is and one that isn't. I bet what I screwed up on, I probably meant to put a -6 in there and just missed it. But the way it's written, neither of those are solutions. Now we could also graph them and see that they don't cross at these points. We're not going to do that. But if I were to graph those, they would not intersect at 2, 4. All right, let's go down here to the next phase. Let's do some graphing. First one we're going to do by hand, and then we're going to start putting our graphing calculators to work. So, very important skill that we got to have is we need to be able to rewrite these in slope-intercept form, because that's normally what we graph better at. So I think on this first one, if I do y equals, if I move the x to the other side, it'll make it negative. So I think that'll be the top equation, which basically tells me that we have a y-intercept at 4 and a slope of -1, which means I'm dropping 1 over 1. And you could darken this whole line in. I'm just going to kind of put dots because I'm looking for them to cross somewhere. If you just kind of put a dot here and then sketch a line, it could be way off by the time you get like, down at the bottom somewhere. So sometimes the dots are kind of good, or use a ruler and get really, really specific. All right, the next one, solving that one for y. Well, I would have, first thing I'm going to do is subtract the 4. So I get 2y equals x minus 4. Divide, divide, divide. So that would be y equals, I'm sorry, Lexi, it's hard for you to see probably. 1/2 x minus 2. So that means we're crossing at a -2. And our slope is go up 1, right 2. Now, if this were a quiz or a test, you may want to graph these with a calculator, because looking at the last test, a few of you guys messed up some negatives and some slope things, so you might want to be perfect when you're doing a quiz or a test. All right, so it looks like we have a good crossing spot. The only thing I'd say here is be careful that you punch it in right, because it looks like the x is 4 and the y would be 0. Now, how can I check to see if that's right? Like if I graphed it right and did it right? I could plug it in. I could come back up here to the top and be like, hey, 4 plus 0, well, that's 4. That checks out. And then I could go 2 times 0 plus 4 equals 4. That checks out. So I feel pretty confident in my graph and in my substituting back in. Things are pretty good. What's up, bub? Well, in this section we're using graphing. In the next section there's going to be elimination or substitution. So there's algebra methods. Graphing is pretty good, but if you don't have a graphing calculator, like if you have two lines that kind of like cross like in here somewhere, you might be like, I don't know, is that a third? Is that a quarter? Where algebra will get you like perfect. So tomorrow is going to be algebra. But all right, here's where you're going to want to get your graphing calculator fired up. So before we do that, let me get mine up on the screen. Looks like we're good. And I'll slide him over a little closer so we all can see what's up. All right, I can't do anything in the graphing calculator until first I'm going to go to y equals and clear those out. I want my y equals blank. Now, if your little plot 1 is highlighted, that means you're still in like that statistics mode. So if this is highlighted and you don't want it to be, if you go up, if you hit enter, it'll like make it highlighted. We don't want it to be. So make sure that that's off. So I'm going to go back up there and hit enter to turn off the highlighting. So now we're not doing a stat plot. We're doing like a real line. Well, I have to actually draw these lines. So let's fix this equation. There's kind of a couple different ways to do this. Anybody got a suggestion how they want to rewrite that one? What are you thinking, Baldwin?
You get y by itself. You put 3x. No. You put 3x on the other side, and then you just reverse everything else and make it all a constant.
Yeah, so that's kind of the traditional way, is you leave y alone, leave it as negative y. You move the 3x to the other side and make it negative. The -2 is okay where it's at. But now we have negative y, and our graphing calculator doesn't want negative y. So we need to multiply everybody by a -1, aka change all signs. So really, this is the nice equation that our graphing calculator is going to like. Now, me personally, that's a two-stepper. So sometimes I'll just throw, like on this one, I might just throw this y to the other side and make it positive and leave my x alone where it's at. And then that -4 I'll throw to the other side. So sometimes I just do that. It doesn't really matter what you do. But a lot of times when I have a -y, I just throw it over there. But who cares? Either way. So my other equation is y equals x plus 4. Well, now we want to see where they cross. So this is where you're going to want to kind of follow the steps. And I kind of wrote them right up here. This is important, and then this is important. So I got to remember these because when I go to tap on my calculator, that's going to disappear for some reason. But 3x plus 2 and x plus 4. So 3x plus 2, enter. And then x plus 4, enter. So I'll give you a second to get caught up and get the 3x plus 2 and the x plus 4 punched in. X is right next to the green alpha button. It says XT, and then there's some Greek letters there. So once you've hit enter and you've got them both locked in, we could graph them and just try to get lucky and see like where they cross. So I could hit graph. And depending on what window you were in last, it might look kind of weird. There's a way, like normally my window, when I print you guys graphs, they always go from -10 to +10 in both directions. If you want to graph like my normal graphs, if you hit zoom and then go down to number 6, which is standard, that's the standard window. So if you hit zoom 6, it'll graph it on a 10 by 10 window, which looks pretty nice for this one. What's up, Davis? Are you in a weird window? Like it's not looking? So go back to your y equals. Is that word plot 1 highlighted?
Yeah.
All right, so you're going to want to go up and then hit enter. And then when you go back down, make sure that it's not highlighted anymore.
Oh, yeah.
So now when you hit graph, it should look a little bit better. But just so instead of going into your window and having to go -10 to 10 by 1, -10 to 10 by 1, you can just hit zoom standard, which is 6. And it'll just change it for you from 10 to 10. All right. So it's kind of hard, though. These little pixels are kind of hard to see where it's at. So you could go to your table. But here's where we're going to use this calculation feature. So I'm going to go to second. And then where it says trace, above it says blue calc. I'm going to hit second calc. And then when you look down, we could find the minimum, the maximum. We want to go to number 5, which says intersect. So I hit number 5. And basically what it's going to say first curve, question mark. So if you notice my little blinking cursor, if I kind of move, it's on that line. It doesn't matter where it's at. Just say, yeah, this line, enter. And then it should jump to the other line. It's going to say, do you want to do this line? And I'm like, yeah, enter. And then it says, okay, are you ready for me to guess? Yes. And it'll tell you right down below, x equals 1 and y equals 5. So if you did this one right, it should say you should have had a solution at 1, 5. So it's, and I'm going to make up a fake problem for us to do again to kind of do that.
Once you are at the point where you have x1 is 3x plus 2 and y2 is x plus 4, what do you press?
So you're going to go to second, and then this trace button. So second calc. And I think mine maybe has already found it. Second calc. And then you go down to number 5, which is find the intersection. And like right now, that blinking dot, I can't really tell what line it's on, so I usually kind of like move it over a little bit so I know what line it's on. I'm like, yep, that line. And then it jumped up, and I'm like, enter that line. And then I have to tell it, yes, guess it. And it gives me a point. Well, it's probably because your window. Hit window, and what does your X min and max and all that stuff say? Yeah, so to fix, like, if you can't see what's going, like you don't even see two lines cross, what you'll want to do is you just want to go to your window, and then you can go down to standard, number 6, and it'll put it on a 10 by 10. But I'm going to purposely make up a new problem that's not going to be in the 10 by 10, and I'm going to show you something cool you can do. So check this out. Somewhere on this sheet, down at the bottom, if you got a little bit of room, I want you to write down 2 new equations, and we're going to make them y equals so they're easier. Let's do y equals 27x minus 192. I'm just making stuff up here. And negative 18x plus 12. I have no clue where those two are going to cross. Like, I know it's probably not going to cross in the 10 by 10 window, at least I'm hoping it's not. So I'm going to show you when you run across a weird problem, what to do. So I think this is going to disappear on me, so I got to write this down. 27x minus 192, negative 18x plus 12. All right, so I'm going to go to my y equals. I'm going to clear out the stuff. So I want to put some new equations in here. I'm going to hit clear, go down, hit clear. So now we're ready to rock and roll. And let's punch in those 2 equations. So it was y equals 27x. I know it's kind of harder to see back there. I'll try to make this bigger. Negative 18x plus 12. So I'm going to punch those 2 in. 27x minus. Some kids this morning accidentally hit the negative key for the minus. Be careful you don't do that, or it'll give you an error. Negative 18x plus 12. Enter. So I got my 2 equations locked in. And what I'm hoping is, when I hit graph, we're not going to hardly see anything because we're probably out of our window. So I don't know, I'm just going to hit graph and see what happens. I see, so it looks like I see both lines, but it looks like if I was going to guess, they're going to cross way down here by like the number 9 key or something. So I could either manually go into my window and say, hey, let's make the y's go really far down negative. But that might be a guessing game. So here's another feature. If you go into zoom, we don't want the standard window, but if you keep going down to number 10, it'll fit it automatically. So it'll like say, hey, we see a cool intersection happening at this point. So let's zoom in there. Guys, some of you are daydreaming. You might want to pay attention because this is like something new I'm showing you. Zoom fit, number 10, will readjust your window kind of automatically. So I'm going to hit enter. And it should redo it. And it's kind of optimized the window for me so that I can see the crossing point. Now, I don't always think it's the greatest window, but it does do at least a decent job of seeing across. So now if I want to find the intersection, what were my steps? Second trace. So I'm going to go second. Really, I'm trying to get to the calculate menu, but second trace, which is calculate. Go down to number 5. I just hit 5. You can scroll down. And now I can see my cursor was on the bottom line. Doesn't really matter where it is, as long as you can tell it's on one of the lines. Hit enter, yep. And now it jumped to the top line, and I'm like, yep. Do you want me to guess? Yep. And this is a nasty intersection point. You know, most of the time, if you just make crap up, it's going to be nasty. So it looks like our intersection point for this equation was 4.5 5, 3 repeating, and then negative 69.6. Enter. Bring it up here. Let me peek at it. Just because I'm all hooked up and don't want to disengage.
Am I seeing your video?
No, there's no video of me. It's
Uh-huh.
just
No, but like, are they talking? We
yeah.
can hear them.
We are hearing you, Claire Baker, for future years.
Fabulous.
All right, so you hit yes for first curve. Now we're on the second one, so you're going to hit yes again, and then yes, we want you to guess.
Oh.
So you got to go enter, enter, enter for first line, second line, and then tell it to guess.
Okay.
Make sense?
Yeah.
Cool. All right. Sir, yes, sir. No, as long as you can see what's going on. Like I could have guessed my own window there if I wanted to, because honestly, when I go back to this standard window, zoom standard number 6, I probably, when I saw this happen, maybe it's going to happen. Where are they? Y equals, it's like working now. Does it look like I have 2 calculators up? Oh, just seeing double vision. I don't know, man. This seems like frozen. Uh-oh. Well, let's just give him a break for a little bit. I'll come back and work with you in a minute, Xander. All right, so the examples all above only had one solution. So that was the normal 2 lines crossed. We're good to go. Now let's look at the 2, what I call the freak cases. There's always some freak things that happen, some weird stuff out there. And these both represent the freak cases. And how I know when I'm going to have a freak case, this is kind of what Baldwin said. But in your mental flow chart, always check slopes. All right, so I look at the slope, and if they're the same, then I'm like, oh crap, we're going to have a freak case. And then from there, we can go one of 2 directions. All right, if you do have the same slope, and you have the same y-intercept, then they're actually the same exact line. And this is where you're going to have a situation where we have infinite solutions. Now, if you find the slopes the same, and then you go and you look at the y-intercepts, and you're like, oh man, you guys have different y-intercepts, well, then that kind of tells me that we have no solution, aka we are parallel, or this one meant you're like right on top of each other. You're the same line. And then normally when you look at slope, if they're different, then you're like, oh good, this is just a normal problem. There's just one solution, and the 2 lines cross, and that's the magic spot. So that's kind of when I mentally go through these problems, looking at the algebra, that's what I'm kind of checking to see what's going down. Well, I'm looking at this, and I can't really see what's happening with the slope because these are in standard form. And this one's like in, I don't know what form it's in. It's just in some weird form. So let's rewrite these. So on the top one, I'm going to just leave the y equals, let's move the 2x over. And I could graph that. I'm like, all right, we're at positive 3, slope of a negative 2, so we're going to drop 2 over 1, drop 2 over 1, 2 over 1. Keep on going. Back it on up. Who was it? Somebody at conferences told me that their kid was disappointed this year because I'm not using enough sound effects in my videos. So I guess I got to up my sound effect game and get it back to where it was. I'm slacking. All right, so the next one I'll just do this traditional. I'm going to get y by itself, so I'm going to move the 9 over. So 6x minus 9 is negative 3y. Divide everybody by negative 3. And I believe that's going to shake out to be y equals negative 2x plus 3. So, whoa, wait a minute. Same slope, same intercept. So when I graph this line, it should be right on top of itself.
Hold up.
So
Wait a minute.
this is an infinite solutions scenario. So on Teacher Made, I'll probably have a drop down where I'll have like 2 or 3 fake points, and then I'll always include a no solution and a infinite. Is there another one? All right, we'll go through this one really quick. Lightning fast. So here we go. I got to be fast. I got to y equals, move the 3x over. And let's try to not even graph this one and just see, like right out of the gate. This one, if I get y by itself, I got the negative 3x, and then I got to move the 2 over. So right now I'm like, oh, same slope. So right now we're at least parallel. But then different y-intercepts. So I know these are parallel lines, which means there's going to be no crossing, no intersection, no solution. If we were to graph it, positive 3, dropping 3 over 1. And then if I do the minus 2, dropping the 3, Luke's favorite. All right. That always gets Luke to smile. All right, man. That wraps it up. Hopefully this gets you ready for the practice. See you.